I'm Elizabeth Frost, the honeybee technical specialist with the New South Wales Government. I'll be talking about spread and symptoms of varroa, both in a geographical sense and symptoms of varroa at both an individual bee level and the overall colony level. There's typically two phases when varroa arrives. Those are the buildup phase, followed by the established phase. The buildup phase is when varroa is spreading geographically. So we've got an image here of New South Wales from the National Varroa Mite Management Program dynamic heat map. This map is made up of mandatory reporting and voluntary reporting from beekeepers. So if you ever find a positive varroa detection, it's mandatory that you report that. And on the varroa heat map, you can see that in the orange to red shaded regions. Those indicate that varroa has been found and reported by beekeepers in those regions. It's voluntary to report negative detections, but those are also valuable. And in this image, you can see those negative reports from a varroa monitoring in the blue tones. In this buildup phase, reinfestation of hives is quite common. So remember, varroa doesn't only infest managed hives, but also feral hives. And feral hives are both unmanaged, unmonitored, and untreated. So during this buildup phase, which typically lasts a couple years from overseas examples, managed hives potentially will get reinfested by either other managed hives that are at varying infestation levels or feral hives that have unmanaged infestations. It's to be determined how long this buildup phase will last in Australia. After the buildup phase, we've got the established phase. So varroa is widespread across the state or multiple states potentially. And these populations are more stable than in the buildup phase. We may still have a smaller quantity of feral hives which present that same issue of unmanaged infestations, crashing populations, or absconding feral hives that the remaining colony potentially could get robbed out. Managed hives pick up those mites and become reinfested. We'll touch briefly on seasonal population demographics. So it's critical whenever a beekeeper or beekeeping industry gets varroa, they get across the seasonal dynamics of varroa and their own hives. So remember, varroa needs honeybee brood to reproduce, and while ever you've got a period in the season and colony life where brood is being produced, you'll have varroa also being produced. So active reproduction happening whenever there's brood in the colony. Now, once varroa is established, after the buildup phase, during the establishment phase, there's impacts on individual bees and eventually on the colony as a whole. So parasitization happens on pupae and also on adult bees. Remembering that varroa reproduction happens under the brood capping while the bee is in this development phase where it metamorphosizes between the pupal stage to the adult stage. And that's a critical period in the development cycle of a honeybee where there's massive changes happening in this larval stage, pupal stage to adult stage time frame, and the internal organs, the external appendages, and the body segments of that bee are being formed. So it's a critical period where if you've got a high infestation of varroa and varroa feeding on that developing bee, some pretty serious things can happen. So it can damage the bee in terms of making it weigh less, impacting the development of its wings, its ability to feed brood, and overall the lifespan of that individual. So high varroa infestations impact bee weight, bee longevity, different behavioral functions, and it also, I suppose, thinking about all those impacts, if that happens to many, many bees in the colony, you'll have a colony that has shorter lived bees that weigh less, and that flows on to foraging, honey production activities. With that, effects on the individuals culminate in a bigger impact on the colony as a whole. So this image is from a varroa development officer in New South Wales from a colony that is highly infested. If you look really closely, you'll be able to see on some of those worker bees, they actually have a mite visible on them. That's typically not what you would see if you were actively managing for varroa. So if you're able to see multiple mites on bees in a small area in the hive, that indicates to you there's a real problem there and you need to check those infestation levels. Monitor actively with an alcohol wash, soapy water wash, or sugar shake to see what those numbers actually are and guide your treatment. At the colony level, remember those individuals have been fed on during the pupation stage, so that metamorphosis period from larvae to adult, and as well as in the adult stage. So the varroa needs to feed on the pupal stage as well as the adult stage of honeybee to get all the food they need for their functioning, and that damages the bees at two different stages, pupation as well as the adult stage. And that all comes together at high infestations to present as a colony that has a decline in a number of things. Brood rearing, foraging, so it's not making as much honey, it's not able to bring back as much pollen, the food that hive needs to survive, thrive, and contribute to a successful business if you're a primary producer beekeeper. And remember, at low infestations, these colony impacts, they may be unnoticeable, which is why we do that active monitoring with our alcohol wash, soapy water wash, or sugar shake. That impact on the colony at high infestation can be visible, and those signs have been seen across New South Wales by our varroa development officers, by beekeepers' activities, doing more monitoring, monthly monitoring, wherever there's brood in the colony. So this can be visible in this image we've got from a varroa development officer in New South Wales, and it shows an adult bee that has abnormally formed wings. So that has occurred during the pupation of that bee in the capped cell. There must have been multiple mites in that colony feeding on that bee to result in those wings forming in a deformed way, non-functional. So that bee's lifespan won't be long in that colony. She won't be able to contribute to foraging, honey production, or pollen foraging. Now, looking at the brood here, we've got a really scattered pattern. So varroa can contribute to reduced brood rearing, brood actually dying, which we can also see in some of these open brood images where the larvae is slumped down or slumping, not nice and glistening little crescent of larvae. It's obviously dead, and in a couple really highly infested colonies, you might actually see that slumping brood and actual varroa in the cells as well. Bees can sense a highly infested cell here or there, so you might see, like in the bottom left, roughly uncapped cell. The bees might actively remove some of that infested capped brood. So this is not where you want to get to. You want to be doing your active monitoring, reporting when you find varroa, making sure you understand what your actual mite levels are in your colony so you can prevent that colony from declining or dying.